In this video, we are going to talk about the discovery of the atomic structure. So, we have seen previously that the modern atomic theory stated that all matter is composed of indivisible particles that are called atoms. But at the end of the 19th century, scientists proved that atoms were not the most basic form of matter. Here we have an experiment that is called the gas discharge tube. The gas discharge tube. So in this experiment, we have a sealed tube filled with a gas at very low pressure, and by application of a high voltage between the two electrodes, so here we have the negative electrodes and the positive electrode, we could observe that electricity flows through the gas in the form of light that we see here. Here is this green light. What was unusual with this experiment is that this form of energy was emitted from the cathode. So it originated from the cathode. So its name was cathode ray. Because it was emitted from the cathode electrode, we called it the cathode ray. Now this light also could be deflected. How? By the application of electric fields, as in this experiment. So we have the same experiment, but we added two plates. We applied a potential difference between them. So one plate was negatively charged and the second plate was positively charged. So what could be observed from this experiment is that this form of energy, when it arrived between the two plates, it was deflected downward. So now we could conclude that this form of energy, or this light, is composed of charged particles. Now the next question was, what is the charge of this particle? Is it a positive charge or negative charge? So here we have some clues. For example, the first is that the cathode was negatively charged. The cathode is negatively charged. Also, when it arrives between the two plates, there is a repulsion effect between the negative charge and the light. So between the negative plate and this light, we noticed a repulsion effect. Also, we could see that between the positive plate and the light, there is an attraction effect. So between the positive plate and the light, we noticed an attraction effect. So because like charges repel each other and opposite charges attract each other, so it was easy to conclude that these particle charge were negatively charged, and we call them electrons, or E-. After that, more experiments were conducted where we could determine the mass to charge ratio of an electron and the charge of this electron. So these were determined. After that, we could calculate with important precision the mass and the charge of a single electron. This mass to charge ratio was determined from the experiment of the extent of deflection. extent of deflection of the light. And this charge, the charge of a single electron, was determined from the experiment of the charged oil droplet. But what was the most relevant to the field of chemistry is that the mass and the charge of a single electron was independent of the gas or the metal electrode. So if we changed the type of the metal electrode, zinc or other type of metals, we also have the same results as the mass and the charge. So it was concluded that these electrons are fundamental particles. So the electron is a fundamental particle. Of all atoms. So atoms were not indivisible. On the contrary, atoms were composed of these fundamental particles that are the electron.